Burton Dreben is our guest in this panel discussion with Professor Quine. He is Edgar Pierce Emeritus Professor at Harvard University and Professor of Philosophy at Boston University. He has published in the areas of logic, mathematical logic, and the rise of analytic philosophy, and has co-authored The Decision Problem with Warren Goldfarb. He has been a long-time colleague of Professor Quine, and their friendship and philosophical proximity are well known. George Boulos replaces our regular panelist, Paul Horwich, for this discussion. In this program, Professor Quine defends his critique of modality and provides an explanation of his characterization of logic. He then clearly expounds his ontological position and discusses his view of and his association with the historical development of logic. Quine also gives his opinion of Tarski's famous work on truth and finally offers his prescription for how much logic the philosopher should be aware of. We go now to Cambridge, Massachusetts to join the discussion. Joining Professor Quine for this discussion are Burton Dreben, Emeritus Professor at Harvard University and Professor of Philosophy at Boston University, George Boulos, Professor of Philosophy at the Massachusetts Institute of Technology, and Martin Davies, Wild Reader in Mental Philosophy at Oxford University. George, would you begin the discussion?
Professor Quine, you were well known for your critique of the notion of analyticity, as well as your critique of, indeed, attack on the kindred notion of modality, that is, the joint notion of necessity and possibility. Let me ask you how you would respond to the following question. Could 1 million have been less than 7?
I think my response to that should be the same as to any question that of the form of any question that asked whether a given mathematical truth could be false or could have been false. There are two aspects to that question. One is what do we do about this modal construction itself, which doesn't reduce to, which doesn't even fit into standard logic, quantification theory, and truth function logic. My answer to that part is that I would raise the level by what I call semantic assent, that is A-S-C-E-N-T, and talk about the symbols. Then I would say that that sentence, whose truth value is being discussed, is mathematically true. Mathematically true, and there's and that is something that we might regard as falling under the heading of necessary truth. And what constitutes its necessity, in my view, is that although mathematics, particularly when we get up, here we are already in number theory in your example. What makes mathematical truth so firm, as I see it, from my holistic point of view, is that when a bundle of hypotheses that has critical mass, in the sense of implying possibility of observational test, implying a connection between two observable situations. When it has critical mass in that sense, it will, chances are, contain not only some sentences of a obviously empirical kind, and some sentences of a completely trivial sort that wouldn't go in practice, that would go without saying, but it would also contain some mathematical laws. When the empirical test then shows that chunk of science is untenable, it implies a connection of observables that doesn't meet the experimental test. Then we know that one or another of the component sentences in that bundle has got to be rejected. We have to start over at that point. And then the question is which one to reject which one the removal of which one might be might turn out to be most opportune in the way of subsequent developments and suggestion of subsequent hypotheses. And our practice is not to disturb the mathematical terms, the mathematical components of that bundle of sentences. Leave the mathematical truths as they are. And why is that our policy? I think it's just the pragmatic matter that upsetting mathematics has such far-reaching ramifications throughout all parts of science that it rocks the boat unnecessarily. We try, in general, to regard it as good strategy to minimize our revisions.
And a follow-up question on a related topic that I wanted to ask is this: you have been even more strenuously opposed to quantified modal logic than you are to the notion, the ordinary, to the notion of necessity as applied in propositional logic. Could you say a word about what you find so particularly objectionable about quantifying in? First of all, I think perhaps would you say what quantifying in is and say why it's such a bad thing?
Yes. You have a modal operator. It is necessary that which covers a certain segment of text, and you have a variable turning up in that segment of text, which is governed by a quantifier which is outside that segment. It's something that leads to trouble, or at least to quandaries, problems, in the modal logic of necessity, also in the logic of propositional attitudes. The de re propositional attitudes, which I reject as an acceptable part of a scientific endeavor, leaving only the de dicto ones. That's an example. The difficulty being in those cases and the necessity case of in the case of the propositional attitudes, because of a mixing of the ontology of the man in the attitude with the man who's attributing the attitude. In the case of modal logic, on the other hand, the difficulty it presents is different. Namely, it leads to essentialism, and I find essentialism philosophically unwelcome. Because if you can quantify into necessity context, then you can say, in particular, you can say for any chosen predicate f, you can say for all x, or necessarily fx, or perhaps for some x, necessarily fx. Therefore, there is something which is essential to any object fulfilling the predicate f. Whereas from my point of view, all attributes are logically on a par and shared on an equal footing by all the denoted objects. From the point of view of logical algorithm, the effect of quantifying in, which makes it unwelcome, or at least complicated matter, both in the propositional attitudes and in the case of modal logic of necessity, is that if you take a special instance of the quantified variable and draw instances, you can get contrary results depending on what term, what name you use to specify the object in many cases. You don't have the in the position of a variable, when that variable is supplanted by an instance, a term, a constant, you don't have substitutivity of identity. Frege's familiar example of evening star and morning star is a case of this.